Welcome to the machine learning like never before. Have you ever wondered how computers seem to know so much about you? How Netflix suggests movies you might like? Or how Spotify creates personalized playlists? The answer is machine learning. Machine learning is a type of artificial intelligence that allows computers to learn from data without being explicitly programmed. Instead of relying on predefined rules, machines can now learn patterns and make predictions based on vast amounts of information. Imagine a child learning to ride a bike. They don't need to be told exactly how to balance or pedal. Through trial and error, they learn from their mistakes and improve over time. Machine learning works in a similar way. It's like teaching a computer to ride a bike, but instead of pedals and handlebars, we use data and algorithms. By analyzing data, machines can identify patterns, make predictions, and even improve their performance over time. This technology is transforming our world from healthcare to finance, transportation to entertainment. Are you ready to explore the fascinating world of machine learning? Let's dive in. Data is the lifeblood of machine learning. It's the raw material that machines use to learn and make predictions. Just like humans need food to survive, machines need data to function. Data can come in many forms, from text and images to numbers and sensor readings. Think of all the information generated every day. Social media posts, online purchases, traffic patterns, weather reports. This data is a goldmine for machine learning algorithms. The more data we feed a machine, the better it can learn. It's like training for a marathon. The more miles you run, the stronger and faster you become. Similarly, the more data a machine processes, the more accurate and reliable its predictions will be. But it's not just about the quantity of data, quality matters too. Just as you wouldn't want to fuel your body with junk food, machines need clean, relevant data to learn effectively. So, the next time you see a CAPTCHA asking you to identify traffic lights or crosswalks, remember that you're helping to train a machine learning algorithm with valuable data. Once we have our data, it's time to train our machine learning model. A model is like a recipe that tells the machine how to process data and make predictions. Think of it as the brain of the operation. There are many different types of models, each with its strengths and weaknesses. Choosing the right model is crucial for achieving accurate results. It's like choosing the right tool for the job. You wouldn't use a hammer to tighten a screw, would you? Training a machine learning model is like teaching a dog new tricks. We show the machine examples of data and tell it what we want it to learn. The machine then adjusts its internal parameters to improve its performance. This process is repeated over and over again, with the model getting better with each iteration. The goal is to create a model that can generalize well to new, unseen data. Just like a well-trained dog can perform tricks in different environments, a well-trained machine learning model can make accurate predictions on data it's never encountered before. Just like there are different ways to learn, there are different types of machine learning. Each type has its own strengths and is suited for different tasks. Let's explore the three main types: supervised learning, unsupervised learning, and reinforcement learning. Supervised learning is like learning with a teacher. We give the machine labeled data, meaning each data point is tagged with the correct answer. The machine then learns to map inputs to outputs, like predicting house prices based on features like location and size. Unsupervised learning is like exploring a new city without a map. We give the machine unlabeled data and let it discover patterns and relationships on its own. This type of learning is useful for tasks like customer segmentation and anomaly detection. Reinforcement learning is like training a dog with rewards and punishments. The machine interacts with an environment and learns to take actions that maximize rewards, like playing a game or controlling a robot. Each type of machine learning offers unique capabilities, making it possible to tackle a wide range of problems. Section 5. Supervised learning. Learning with a teacher. Imagine you're teaching a child to identify different fruits. You show them an apple and say apple. You repeat this process with bananas, oranges, and grapes. Eventually, the child learns to associate the name of the fruit with its appearance. This is similar to how supervised learning works. In supervised learning, we provide the machine with labeled data, meaning each data point is tagged with the correct answer. This labeled data acts as the teacher, guiding the machine to learn the relationship between the input features and the desired output. For example, we could train a supervised learning model to predict house prices. Our labeled data would consist of information about houses, such as their location, size, number of bedrooms, and of course their actual sale price. By analyzing this data, the machine can learn the relationship between these features and the target variable, which is the house price. Once the model is trained, we can use it to predict the price of new, unseen houses. We simply input the features of the new house, and the model will use what it has learned to estimate its price. Supervised learning is a powerful tool for tasks like image classification, spam detection, and medical diagnosis. Section 6. Unsupervised learning, finding hidden patterns. Imagine you're a detective investigating a crime scene. You have a lot of evidence, but no clear suspect. Your job is to analyze the evidence and find patterns that might lead you to the culprit. This is the essence of unsupervised learning. In unsupervised learning, we don't provide the machine with labeled data. Instead, we give it a set of data and let it discover patterns and relationships on its own. It's like giving someone a jigsaw puzzle without showing them the picture on the box. One common application of unsupervised learning is clustering. Imagine you work for a marketing company, and you want to group your customers into different segments based on their purchasing behavior. You can use a clustering algorithm to analyze their purchase history and identify groups of customers with similar preferences. This information can then be used to tailor marketing campaigns and improve customer satisfaction. Unsupervised learning is particularly useful for tasks like anomaly detection, where the goal is to identify data points that are significantly different from the rest. For example, a credit card company could use anomaly detection to identify fraudulent transactions. Section 7. Reinforcement learning. Learning from experience. Imagine training a dog without giving it explicit commands. Instead, you reward it with treats for good behavior and discourage unwanted actions. Over time, the dog learns to repeat actions that lead to rewards and avoid those that result in punishment. This is the basic idea behind reinforcement learning. In reinforcement learning, an agent interacts with an environment and learns to take actions that maximize rewards. The agent doesn't receive specific instructions on what to do. Instead, it learns through trial and error. Just like a child learning to ride a bike, the agent experiments with different actions and observes the consequences. One of the most impressive applications of reinforcement learning is in game playing. For instance, AlphaGo, a reinforcement learning program developed by Google DeepMind, made headlines in 2016 when it defeated a professional Go player. Go is a complex board game that was once considered too difficult for computers to master. Reinforcement learning is also used in robotics, where robots can learn to perform tasks like grasping objects and navigating complex environments through trial and error. As this technology continues to develop, we can expect to see even more innovative applications in the future. Section 8. Machine learning in action, from recommendations to robots. Machine learning is no longer a futuristic concept. It's all around us, shaping our lives in countless ways. From the recommendations you see online to the cars we drive, machine learning is transforming various industries. One of the most well-known applications is recommendation systems. When you shop online or browse streaming services, machine learning algorithms analyze your past behavior and preferences to suggest products, movies, or songs you might enjoy. These systems have become incredibly sophisticated, learning your tastes and predicting your next purchase with remarkable accuracy. In healthcare, machine learning is being used to diagnose diseases, develop new treatments, and personalize patient care. Imagine a future where algorithms can analyze medical images to detect cancer at its earliest stages, or predict patient outcomes with greater accuracy than human doctors. Self-driving cars are another area where machine learning is playing a pivotal role. These vehicles rely on a suite of sensors, cameras, and advanced algorithms to perceive their surroundings, make decisions, and navigate roads safely. While fully autonomous vehicles are still under development, the progress made in recent years is a testament to the power of machine learning. Section 9. The future of machine learning. Challenges and opportunities. Machine learning has come a long way, but it's still a relatively young field with immense potential for growth. As we venture further into the world of intelligent machines, we face both exciting opportunities and critical challenges. One of the biggest challenges is developing machine learning models that are fair, unbiased, and ethical. Since these models are trained on data, they can inherit and even amplify existing biases in the data. For example, a facial recognition system trained on a data set that primarily features white faces might perform poorly on faces of other ethnicities. This could lead to discriminatory outcomes, highlighting the need for careful consideration of data bias and fairness in machine learning development. Another challenge is ensuring that machine learning is used for good and not for malicious purposes. As with any powerful technology, there's always the risk of misuse. It's crucial to establish ethical guidelines and regulations to prevent the development of harmful applications, such as autonomous weapons systems or surveillance technologies that violate privacy. Despite these challenges, the future of machine learning is bright with promise. As our understanding of this technology deepens and we gather even larger and more diverse datasets, we can expect to see breakthroughs in areas like personalized medicine, climate change modeling, and scientific discovery. Machine learning has the potential to revolutionize our world for the better, but it's our responsibility to guide its development and ensure that it benefits all of humanity. The future is in our hands and it's up to us to shape it wisely.